Jai Hind everyone. I am Dr. Suman Gothwal, working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College. So today we are going to discuss the transportation problems, and which is a part of the industrial engineering with subject code KME 503. So it is one of the most important topic of this subject. So what we are going to discuss today is, first we will discuss about the different outlines that we are going to discuss in details in today's lecture. First we will see what are the transportation problems and how we can define the transportation problems. Then we will classify the transportation problem into different categories, means different techniques, what are the different techniques to solve these problems, and then we will discuss each of the technique or each of the method with the help of the suitable examples. So first we have to define the transportation problem. So transportation problem, in case of the industry, we know that the material is transferred from one place to the another place, or we can say that it is distributed between the supplier and the distributor. Okay. So in case of the transportation, our main objective should be to minimize the cost. Okay. So here the objective will be to minimize the total cost of transportation from the supply center to the demand center, okay, or the distribution center. So the cost will lie between the demand and the supply. Our objective will be to minimize this cost. So we have defined this transportation problem into a matrix, okay, and it is known as the mathematical model. So basically when we solve the transportation problem, we can have the statement in terms of the, or we can have the problem in terms of the descriptive statements, and then we have to formulate the problem. So when we will formulate the problem, we will convert the our problem into the form of the matrix, which is known as the transportation matrix. So in this case, we can see there are different terms associated with this matrix. First we will see D1, D2, D3, D4. These are basically the distribution center, and this S1, S2, S3 are indicating the supplies. Okay, these are the supply and these are the demands, and here we can see that this is the demand. In the last row we indicate the demand, and in the last column we indicate the supply. Okay, so we can say with respect to S1 the total supply is 7, with respect to S2 the total supply is 9. Similarly we can say with respect to D1 the total demand is 5. Okay, means this distribution center has a demand of 5, the requirement is of quantity 5. Okay, now what are these terms? These terms are basically indicating the cost. The cost will be between the S1 and D1. So S1 and D1 the cost will be equal to 9. Between the S1 and D2 the cost will be equal to 30. And what we will do in this problem, we will calculate the transportation cost, and we can implement different techniques over it, and we will see how we can achieve the minimum cost. So there are some steps which are associated with the transportation issues. First of all, we have to formulate our problem. We will formulate the problem, means we will convert the descriptive statements into the form of the matrix. Then we will check whether the demands are equal to supply or not. If the supply and requirements, or we can say the demands, are equal, it means our problem is balanced and we can find out the solution. But if the case come like the supply is not equal to the requirement or the demand, then in that case we will create a dummy source or the destinations as per our issue, and to create the balancing. Okay, means if our problem is not balanced one, then we will balance it by adding one dummy row or the column, one dummy supply or the demand. That will depend on our current case. Then we if so the second step was, first we have to balance our problem, and after balancing the problem we will determine the initial basic feasible solution, which is known as the IBFS. Then we can check the optimality also, means whether the solution that we have find out, we have determined, is the optimal or not. So, for checking the optimality, we will check these conditions: m plus n minus 1 is equal to number of allocations. So, this is the important criteria for checking the optimality of the solution. What is m? M is basically the number of rows in our transportation matrix. These are the number of columns. Minus 1, it should be equal to the total number of allocations. Then we will update our solution. So, these are the different steps that we are going to use in solving the transportation problems. Now, there are different techniques for finding out the initial basic feasible solution, and these techniques we will implement after checking whether the problem is balanced one or not. Okay. So, these are the different techniques which we are going to discuss in today's lecture. First one is the northwest corner method. The second one is the least cost method. The third one is the Vogel's approximation method, which is known as the VAM method also, and it is also known as the penalty method. Then we have the row minima method and the column minima method. So, these are the different techniques which we will discuss in coming slides. So, first we have taken one example which is related to the transportation issue. So, in this example we can see here the problem is given in the terms of the descriptive statements, and our first step will be to convert these descriptive statements into the form of the transportation matrix. So, how we will convert it? First we will see what is given to us. A dairy farm has 3 plants which are located throughout at state. The daily milk production at each plant is as follows. At the plant 1, there are 3 plants, plant 1, 2 and 3, and this is the daily production of the milk: 6 million liter, 1 million liter and the 10 million liter. Okay. And each day the farm must fulfill the needs of its 4 distribution center. So, there are 3 plants and 4 distribution center, and this dairy farm have to fulfill the needs of the distribution center. The minimum requirement at each center is also given to us. So, at the distribution center 1, we can see here the requirement is 7 million liter. The distribution center 2 has the this is the 50 million. Okay. At distribution center 2, the requirement is 15 million liter. At 3, we have the 3 million liter requirement, and at distribution center 4, the requirement is 2 million liter. So, the daily production is given to us at different plant location, and the requirement at the different distribution center is also given to us, and the cost of shipping 1 million liter of milk from each plant to each distribution center is given in the table in 100 of rupees. So, one table is also provided, and which is in which we have the cost of shipping from the plant to the distribution center. So, this cost table is given to us, means when the plant 1 is supplying the milk to the D1 distribution center, this is the D1, there are 4 distribution center. So, these are the distribution center and there are 3 plants. So, the P1, P2, P3 are indicating the plants, and the cost is given, means when we are supplying the milk from P1 to D1, the cost is rupees 2, P1 to D2, the cost is 3. So, similarly all the costs are given. now we can see in the last column there is supply, okay, means the P1, the supply is for P1, the supply requirement is the 6. For P2 it has supply quantity of 1. P3 has the supply quantity of 10. Now here the demands or the requirement is given of the distribution centers. So we can see here that D1 has the requirement or the demand of 7 million liter, the D2 has 5, 3, 2 and the 17. So these are basically, sorry, this is not given to us, this is given to us for the D4. Now what is this? This is here basically our first criteria was to check whether the problem is balanced one or not. So what we will do, we will check that whether the supply is equal to requirement or demand or not. So we can see here this is the supply, 6 plus 1 plus 10 is equal to 17. This is the total supply. Demand is 7 plus 5 plus 3 plus 2, which is also equal to 17. So we have written 17 here. So we can see here that the supply is equal to demands, means our problem is balanced one. So we can find out the solution, and this solution is known as the initial basic feasible solution. So we are going to discuss the different techniques. So first technique that we are going to use in this problem is the northwest corner method, okay, and there are some steps for this technique, means we will follow these steps. Starting from the cell 1 1, proceed horizontally if di is less than Si, means because it is the northwest corner method, so we will select the cell 1 1. Okay, we will start from cell 1 1 and we will proceed horizontally if di is less than equal to Si, means demand is less than supply. We will proceed diagonally if di is equal to Si, and we will proceed vertically if di is greater than Si. Okay. So these are the different steps that we are going to follow. Now we have already checked this criteria, total demand is equal to total supply, and we will check this feasibility condition also, and which is the necessary requirement for checking the optimality. Okay, m plus n minus 1 is should be equal to number of allocations. So now we will start how we can find out the solution. So first we have to select the cell 1 1, C11. So this is the cell from which we are going to start this problem. So we can see, so against this cell P1, the supply is 6 and the demand is 7. So we can, because the supply is 6 and the demand is 7, so we can satisfy the demand of 6 only. Okay. So here the supply is 0 with P1, but the demand that is not satisfied is 1. The demand of 6 is already satisfied. Okay. Now next what we will do, we will check how we will move now. So we will check the supply and the demand relations. So here the case was di is greater than Si. Okay. So this is the conditions where we will follow vertically. So when we will follow vertically, then what will be the next cell that we select for the allocation will be 1. So in this case we will see here the supply is of 1 and the demand is also of 1. So it will satisfy the quantity 1. So it will satisfy the demand 1. So here we will have the supply 0 now, and it will also become 0. Okay. Now we will see how we will move. So it was the case where di was equal to Si. So when this is the case, then we will we proceed diagonally. Okay. So what we will do, we will go to this cell. Okay. And now we will check the demand and supply against this cell. So, we can see here the supply is 10 and the demand is 5. So, we can satisfy a demand of 5 here. Okay. And it here the still the supply of 5 is left with us. So, we can see here. So, here the case was 10, means the SI was greater than DI. So, when this is the case, then we will move horizontally. So, we will come to this cell. Okay. So, when we will come to this cell, we will see again this the supply is 5 and the demand is 3, requirement is 3. So, we will satisfy this requirement of 3. So, here it will become 0 and it will become 2. Okay. Now, again we will see the SI was greater than DI. So, this is the case, this is the criteria which we will follow, means we will move horizontally. Again we will move horizontally, means we will come to this cell. Okay. Now, we will see against this we have the supply of 2 and the demand is also 2, means we will satisfy the demand of 2 here. It will become 0, it will become 0. So, these will be the final number of allocations. Okay. So, how we will find now we have allocated the cells. Now, we will find out the total transportation cost and this will be the initial basic feasible solution IBFS. Okay. Now, how we will find out the cost? We will see the allocated cells only and we will multiply these terms. So, first 2 into 6 plus 1 into 1 plus, then we come to this 8 into 5 plus 15 into 3 and plus 9 into 2. Okay. So, it will become, this will become 12 plus 1 plus 40 plus 45 plus 18. Okay. So, this will become 116. So, this will become the transportation cost for this particular problem with the help of the northwest corner method. Okay. And this is the initial basic feasible solution. Now, we come to the second technique or second method, that is the least cost method. So, what we will do in this case, this is the problem that is given. We are taking the same example for all the methods for the better understanding. So, this is the same matrix which is given to us and I have drawn here the 4 matrix, okay, for the simplification or for the better understanding. So, this is our basic method. So, we have already checked that it is the balanced problem. So, it means we can find out the solution. So, in case of the least cost method, for what we do, we will find out the cell which is having the minimum cost. Okay. And if there is 0 in the cost matrix, then it will be considered as the minimum cost of that particular matrix. Okay. So, here we can see in this case we have the minimum cost in this cell is 0. So, we will select this cell. Okay. So, first allocation will be provided in this particular cell. So, we can see the demand or supply against this particular cell, the supply is 1 and the demand is 5, but if the supply is 1, then obviously we can satisfy the demand of 1 only. So, here it will be 4 and it will become 0. Okay. Now, what we will do, because it is in case of the plant P2, now no supply is left. So, we will not consider this particular plant for the further steps. Okay. So, you can see here in my second matrix, I am drawing the number, this is second, this one is third and this one is fourth. Okay. In my second matrix, I have not shown this P2. because here the supply already become 0. So, here we will consider this. So, this will become same 2, 3, 11, 7, 6. This will also be same P3, 5, 8, 15, 9, 10, but this will change. This demand row will change. Now, it is 7, but it is 4 only, because we have satisfied the demand of this particular cell. So, now it is 4, then 3 to 17, 3 to 17. So, we will draw the matrix for each allocation. Okay. Now, we will find out the least cost in this particular matrix. So, what we will do, we will check. So, we can see here this is the least cost in the cost matrix. So, means our next allocation will be in this cell. So, here we can see the supply is of 6 and the demand is of 7. This is 7. So, we can satisfy the demand of 6 only. So, here we will write down 6, here it will become 1 and it will become 0. So, this is our second allocation. So, in this case we can see here again the supply against P1 became 0. So, we will not consider this particular plant in the further steps. Okay. So, I have again drawn this particular matrix and you can see here I have considered only the P3 plant, okay, this plant. So, now we will see what is the least cost in this particular matrix. So, we can see here the least cost is this one. So, our next allocation will be against this cell. So, we can see here the supply is 10, but the demand is of 1 only, or we will change the, in this matrix we will change the demand as per our current demand. So, here we can see here only 1 is there. Okay. Now, we can see the supply is of 10, but the demand is of 1. So, we will satisfy the demand of 1 here. Now, it will left with 9 and it will become 0. Okay. In my next matrix, you can see here I have not considered this particular column, because all the demands against the distribution center D1 are satisfied. So, we will draw the D2, D3 and D4 here. We will consider only these 3 distribution center and the plant P3. Now, we will check what is the minimum cost. Minimum cost is against this cell and the demand is of 9 and the supply is of 9 and the demand is of 4 here. So, we will supply the demand of 4. It will become 0, it will become 5. Okay. Now, because only 2 distribution centers are left, I will show the remaining allocation in this cell, in this matrix only. Then we will check what are the next least cost. So, we can see here the next least cost is 9. So, we will allocate against this particular cell. So, we can see here the supply is 5, but the demand is of 2. So, we will satisfy the demand of 2 here, okay, and it will left with 3. So, it is against cancelled and now the last cell is left. So, we can see here the supply is of 3 and the demand is of 3. So, we will allocate 3 here. It will become 0 and 0. So, it means we have allocated all the cells. Now, we will find out the transportation cost. So, here I have drawn here the basic matrix and we will show all the allocations in this cell, so that we can easily find out the transportation cost. So, we see here first allocation was against this particular cell, one was against this cell, then it was 1, it was 4, it was 3 and it was 2. These were the allocations which we have discussed in the last slide. Now, we will find out the transportation cost. So, for the transportation cost, we will multiply 2 into 6 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. So, it will become 12 plus 0 plus 5 plus 32 plus 45 plus 18. So, it will become 112. Okay. So, this is the cost, total transportation cost in case of the least cost method. Okay. Now, we will discuss the next technique, that is the Vogel approximation method, or we say the VAM method or the penalty method also. So, there can be two cases, one is the minimization problem and the another one is the maximization problem. So, first we will discuss the case of the minimization. So, if the minimization problem is given to us, then what we will do? We will calculate the penalty against each row and the column. So, how we will calculate the penalty? For calculating the penalty, we will subtract the smallest and second smallest element in each row or column. Okay. Then we will select the row or column with the highest penalty and we will allocate the minimum cost. Okay. First, we will find out the penalties and we will select the penalty which is maximum. Okay. And then we will allocate the minimum cost. In case of the tie, we can select any cell. After one allocation, we will calculate the penalties again and we will repeat these iterations until all the allocations. Okay. So, this is the case of the minimization problem. In case of the maximization problem, what we will do? We will take the difference of highest and second highest. In the minimization problem, what we were doing? We were taking the difference of the two minimum cost. But here we will take the difference of two highest cost in each row and column. After that, we will select the row or column which is having the highest penalty and we will allocate the highest cost. In that case, we were allocating the minimum cost, but in this case, we will allocate the highest cost. In case of the tie, we can select any cell. After one allocation, we will calculate the penalties again and we will repeat the iterations until all the allocations. So, these are the steps we are going to follow in case of the Vogel approximation method. Now, this is the same matrix which we have used in our two techniques. So, what we will do in this penalty method, basically we will find out the penalties. So, and for finding out the penalties, I am finding out the penalty for the first time. So, I am writing down P1. So, we will find out the penalty against each row and each column. So, we will select the two minimum cost, 2 and 3. So, penalty will become the difference of these two, means it will become 1. It will become 1 here and it will become 3 here. In case of the columns, we can see here the two minimum cost are 2 and 1. So, the difference will become 1. Here it will become 3, 5 and 6. Now, the next step was we will select the maximum penalty. So, we can see here this is the maximum penalty here. So, we will select this column. Now, how we will allocate the cell? We will see which cell is having the minimum cost. So, we can see here this is having the minimum cost. So, first allocation will be provided against this cell. Okay. So, we can see here the supply is 1 and the demand is 2, means we can satisfy the demand of 1 here. It will become 0 and it will become 1. So, because the supply become 0 against this plant, we will not consider this one. Okay. Now, in this case, you can see here we have considered P1 and P3 only. Now we will again calculate the penalties P2 here, okay, and we will repeat the same step. So here it comes out to be 1 and 3, and here it comes out to be 3, it is 5, it is 4, and it is 2. Now we will select the maximum penalty. So we can see the maximum penalties here. Now we will see the what is the least cost against this column. So we can see this is the least cost. So we will allocate against this cell. So here the supply is of 6 and the demand is of 5. So we will satisfy this demand. It will become 0, it will become 1. Okay. So because it became 0 means all the demands of the D2 distribution center are satisfied. So we will not consider it again. So we will not consider this D2 in the further allocation. Now we come to this. In this matrix you can see we have considered only D1, D3 and D4. Okay. So we will provide the next allocation now. So we have calculated the penalty here. So it comes out to be 3, 4 and 2 against D1, D3 and D4, and it comes out to be 5 and 4 against P1 and P3. So now we will select the penalty which is having the maximum value, and we can see here this one is the maximum value. So next allocation will be provided against this row. So here the minimum cost is this. So we will provide the allocation here. So we can see here the supply is of 1, but the demand is of 7. But we can satisfy the demand of 1 only. So this will become 0, it will become 6. Okay. So now we will not consider this for the further case. Now if we see what is the least cost, because only one row is left, so we cannot find out the penalties further. Now we can see here the least cost is this one. So we will allocate against this particular cell. So we can see here that the supply is 10, but the demand is 6. So we can satisfy the demand of 6 here. So it will become 0 and it will become 4. Okay. So now the next cost, least cost, is this one. So here the demand is of 2, but the supply is of 4. So we will satisfy the demand of 2. It will become 0 and it will become okay. It was 5, it will become 3 here. Now the 15, this is the last cell. So here we can see here the demand is 3 and the this one supply is 3. So it will we will satisfy 3 here. Okay. So in this way we will allocate all the cells. Now we will allocate all the cells here to find out the transportation cost. So what we have assigned here, it was 1, it was 5, okay, it was again 1, it was 3, it was 6. These were the allocations. We can see here in this. These were the allocations basically. Okay, it was not, it was 1. Okay. Now we can find out the transportation cost. These are the allocations, and here it is 1. So it will become 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 and 15 into 3 plus 9 into 1. So it comes out to be 102. So if we compare all the 3 techniques, then we can see here that we get the minimum cost here. So it is the it is giving the most approximate cost. So it is a very important method or technique that we use in finding out the solution. And this is the row minimum. In this basically what we will do, we will calculate the minimum cost, okay, in case of the each row, and then we will assign the allocations. And in the same way this we can find out the transportation cost, and same we can perform in case of the column minima. Means we will basically assign the value that is the minimum value. against the column we will see what is the minimum value, and we will assign the cost here, and we will find out the transportation cost. So these are all the techniques that we can use for calculating the transportation cost, and we can find out the initial basic feasible solution. So this is all from my side in the regarding the transportation cost. Thank you so much.